In this video, I wanted to teach you or review how to complete the square within a quadratic function. And just to remind you about the goal of completing the square, it is to take a expanded polynomial of degree 2 and write it in a completed square form. This is different than factoring a polynomial. Like what you probably remember from algebra is if I have polynomials like this, I could make a magic x or whatever methods of traditional factoring you could to factor this polynomial. This is a different procedure. And factoring is important, but we're not going to review basic factoring techniques in this class. We will actually talk more about factoring in chapter 3, and I'm going to teach you, well, maybe it's some new methods of factoring. I mean, a lot of you may have seen them too, but we're going to review different methods of factoring when we get to chapter 3, but not for now. But anyways, completing the square, I have a little box in the packet which is like a little bit of a step-by-step instructional for completing the square. It is not perfect because I made this quite a while ago, but I'll try to explain what I mean in each of these steps. But basically, when completing the square, there's a series of steps we can go through to get it looking like this, looking like this. One step is noticing that within this, if we were to expand it out, we could make a comparison from standard form to quadratic form. But notice that here we have ax squared, but in the vertex form, we have a parentheses x squared. So this, like the first step to actually completing the square is always to factor out the leading term from the first two terms only. And there's a reason why you only want to do it from the first two terms. And in this case, notice there is no leading coefficient. Sorry, I meant leading coefficient. Factoring out the leading coefficient. You don't want to factor out the whole term. That would not make sense. Second step, so basically in our function f of x here, we don't actually need to do that because there is nothing to factor out. But for example, in polynomial g of x here, we'd want to factor out the -3 and only from the first two terms. So basically, I would want to pull out the -3 like that. Also, what I like to do is just leave the +24 on the outside because that I don't want to mess with. And I'll try to explain why as we go through this, but not for this immediate second. And basically, that would leave me with, if I'm factoring out -3 from x squared, that would leave me with just x squared. And from -6x, remember if I'm factoring out -3, that is the same as dividing by -3. So -6 divided by -3 would leave us with +2x. And that would be step 1 in both cases. And I did not have to do that here. So step 2 says take the coefficient on x, call this b, cut it in half, and then square it, which is what the second blank is. If you have printed this out and are taking notes, that's what the blanks are. And so actually on this one, what I would recommend is, since there was no step 1, we didn't have to factor anything out. You could always technically factor out 1, but how I would actually just write it is just take the first two terms, group them in parentheses, and write the +5 on the outside. And notice that that way it has the structure that looks a little bit more like this. And again, the reasoning for this is because notice in the vertex form, it looks a lot like that. And that's, the parentheses come in handy. But the next thing that you'll notice, which is a little bit of a problem, is we have x squared and x, and that's a little bit different from vertex form, which just has x and a number, all quantities squared. So kind of the goal here is to take the square and move it out here, but we can't just do that willy-nilly, and that's what step 2 is all about. So there's always a magic number, which basically if you add it on the inside, right here, it will allow you to factor the polynomial and complete the square. So I'll just do a couple examples to show you how this works, and then I'll have you practice it with the homework and stuff. But basically, how you know the magic number or the special number, whatever you want to call it, to do is this is the coefficient I'm calling b here. Notice in this case it's exactly the same as lowercase b, but I'm going to call it capital B because sometimes it changes. Like down here, notice that coefficient, since I first had to factor out the -3, that b has changed to now +2 instead. So what you could remember is capital B is lowercase b divided by lowercase a. -6 divided by -3. But I wouldn't recommend remembering all that stuff because trying to memorize little things like that I think are easier to forget. And what I think is easier to remember, in my opinion, is the strategy. So that's kind of what I'm focused on here. But basically, what I want to do with this number is first cut it in half and then square it. So I could kind of keep track of that over here. What I have is 4. I'm going to cut it in half, which is 2, and then I want to square that. So that would be 2 squared or 4. So in this case, it's actually the same value, the same number that I started with. And what it says for step 3 is to add the result b over 2 quantity squared inside the parentheses. So basically, like I said, what I want to do is sort of insert this number or slot it into my quadratic function. So I'm going to create a new line. Let me use black once again. X squared plus 4x. And I'm going to go ahead and just do that in green just for note-taking purposes and just for the sake of my explanation. And let me erase this as well. So sometimes I like to write a bunch of stuff to try to explain my thinking that's not necessarily correct notation or stuff that I would write. So sometimes I might erase stuff like this just to, because it's not really something you would usually want to write. But, I like to underline stuff to show you what I'm thinking, if you see what I'm saying. But basically, take this, cut it in half, square it, add it inside. So step 4, what it says to do is compensate outside the parentheses, and step 5 would be to factor the parentheses to complete the square. Well, the whole point of adding that very specific number in there is notice that this creates another quadratic within the parentheses. And this quadratic should always factor, and it should always factor in a very specific way. So this polynomial would factor as x plus 2 times x plus 2, right? And if you go ahead and FOIL that out to check, that would be x squared plus 2x plus another 2x plus 4, and that would add up to x squared plus 4x plus 4. So notice that it will factor, and the reason why we call it completing the square is notice that it not coincidentally factors as the same thing times itself. Or, of course we could rewrite that expression since it's multiplied by the same thing as x plus 2 squared, because when you square something, that's exactly what it means, right? Is the same quantity multiplied by itself. But the thing that I skipped over was step 4, which is to compensate outside the parentheses. And basically, that was because when I added 4 in this equation, and you were probably thinking to yourself, wait, can you just do that? And the answer is no, because the original function, x squared plus 4x plus 5, would not be the same if I've just add 4 to it, right? Because that would be changing what this looks like. And actually what that results in is a vertical transformation of the function. And we'll talk more, we'll review that in a later video. But basically, so I didn't really specify what compensate means, but basically what you always want to do is add the opposite on the outside of the parentheses. So to the second number, this number will typically change because, as I said up here, right, c and k are not usually the same thing. Here, this is c. C is usually going to change by this compensation process. And the opposite of adding 4 is subtracting 4. So in that same step where I added 4, I really want to subtract 4 on the outside, because notice that plus 4 and minus 4 would cancel, and what that would leave me with on this statement here is exactly x squared plus 4x plus 5. So when I said you're not allowed to add 4, well, you're allowed to add 4 if you want to, as long as you subtract 4 also, and the net effect of this is nothing on the original function. And again, the reason why I'm adding 4 and subtracting 4 is so that I can complete the square, and then all I have on the outside left over is plus 5 minus 4, which is of course plus 1, and that finishes our process for completing the square. And now we would say that this quadratic is expressed in vertex form. And since in vertex form, there's information here, which means that right here and here would be the location of the vertex. And the last little thing about this is that, well, it's always x minus h. And if you're wondering, well, what happens if it's plus? What does that mean? That just means that h is at, and remember that the vertex is a point location of where the vertex is located on the graph. that would just mean that h is -2 and k is +1. So this video is getting too long. We'll continue this in the next video. Sorry, I'm kind of cutting it off here. But we'll keep talking about this and do a couple more examples of completing the square. And we'll talk more about the graphs of parabolas and vertex next time.